Hi and welcome to the next lesson in the memory series. This lesson's topic is memory examples. So far we've talked very generally about memory. Before discussing even further about memory in a more formal fashion, I want to jump straight into a few examples to give you a feeling of how the memory is like and how is it like to work with memory. Everything that we are going to see will be explained later in a more detailed fashion, so don't worry if you don't follow everything completely. Let's begin with the first example called reverse.ascend. Before even looking inside and seeing the source code of this program, let's assemble and run it and see what it does. I open the console and now I'm going to assemble this program, and next I'm going to run it. This program expects 5 numbers as input. I know this because I wrote this program. Let's give it 5 numbers, for example 1, 2, 3, 4 and 5. As output, I get exactly the same 5 numbers, but in reversed order. As you can see here, 5, 4, 3, 2, 1. Let's try something else. Maybe 1, 1, 4, 4, 5. I get as a result again exactly the same 5 numbers, however, they are in the reversed order. 5, 4, 4, 1, 1. Interesting. By now you probably know that this kind of problem is hard to solve using only registers. We got to have some more containers to hold numbers if we want to reverse 5 numbers. Therefore, this is a pretty good example of using the memory. It is a bit artificial, but it might be one of the first programs that cannot be done only with registers. We got to have something else, and this time we are going to use the memory. Let's take a look inside the source code. Maybe the first thing to notice here is this new section called the data section. We have already discussed a bit about sections. We have seen the text section, for example, and we have also seen the iData section. The text section, which is here, contains the code. And the iData section contains references to external functions, external pieces of code. Here we can't see it because it is inside training.inc somewhere. The data section is something which we haven't seen before. Note that it has some interesting properties, which are data, readable, writable. As an example, it doesn't have the executable property. That is because we don't have any reason to execute this part of the program. This part is supposed to keep data. Let's see what is inside this section. As we can see, we have this comment says 5 D words. And then we have this line, which is a bit strange. It begins with keep nums, which is basically the name of this location in memory. It is some kind of a label. Just like start is a label, keep nums is another label. Next we say what we want in this location, which is, in this example, data D word, 5, duplicate, 0. It means that we want to hold space for 5 D words. 5 D words which are initialized to be 0. Just to make sure that we understand what it means, 5 D words are exactly 20 bytes, which means that we are going to have exactly 20 bytes in this location, inside the data section. Why would we want this? it would be very useful to store the numbers that we read from the user. I remind you that we read exactly 5 numbers. Therefore, having an array of size 5 dwords is going to be pretty useful. Let's continue with the code, which begins here, just as usual. We can see that the code consists of 2 main parts, or maybe 2 main loops. This is the first loop, and this is the second loop. At this point, you don't have to follow everything that I say about this code, because you could probably do it later with yourself. It might be even the better option. But I just want to explain generally what happens here and how do we use the memory. This is the part that I really care about at this moment. Let's begin by describing the first loop, which is about reading all the numbers and keeping them in memory. We are going to read exactly 5 numbers, and we can see it from this instruction, move ECX 5. Next, let's see what happens in every iteration of the loop. First, we decrease ECX by 1, which means that probably this loop is going to happen 5 times, which is reasonable. Next, we read a number from the user using this instruction, call read hex. The number will be inside EAX. Now we do something maybe a bit strange. We take ECX, copy it into ESI, then we multiply by 4 here, and finally we add it to keep nums. Basically, what we get here is that ESI equals keep nums plus 4 times ECX. If you think about it for a moment, you will realize that this address, which equals keep nums plus 4 times ECX, is exactly the location of dword number ECX. For example, if ECX equals 0, it points exactly to the beginning of the array, to the location of the first dword. However, if ECX equals 4, it is going to point to keep nums plus 16, which is exactly the location of dword number 5. So this is about calculating the address. And as opposed to some high-level programming languages, in assembly you have to do it manually. You have to understand yourself the size of every element in your array. We are going to deal with this subject in a more detailed fashion later, but for now just make sure that you understand. The 4 is here because every dword is exactly of size 4 bytes. If we had an array of words, we would have 2 instead of this 4. Next we have a very interesting instruction, which is really a new thing here. We haven't seen such instruction before. This instruction is supposed to store the number that we read from the user inside dword number ECX. Let's explain this instruction, or maybe let's explain the syntax. The part that we understand is on the right. We are going to store the value inside EAX, which is basically the value that the user gave us. The destination is called here dword open brackets ESI close brackets. I want to deal with the brackets first. Whenever we have brackets inside an instruction, inside one of the operands, it usually means that we are going to deal with memory. Not always, but really most of the times, brackets mean access to memory. It might be reading or writing. Whatever we have inside the brackets represents the address. In this case, we want to access the memory at address ESI. Therefore, we have ESI inside the brackets. You might be wondering, why do we have this dword here? This dword is a hint for the assembler. it tells the assembler that we are going to perform a data transfer of size 4 bytes, which is a D word. Many times the assembler would be able to guess. For example, in this case, the assembler can really guess the size of the data transfer, and that is because the assembler knows the size of EAX. He knows that this should be a data transfer of size 4 bytes. However, in some cases, maybe for example if we had here some constant, the assembler will not be able to know. And in those cases, you have to supply the assembler some kind of a hint. So you have to write here, for example, D word, or maybe word, or byte, or something of this type. The next part of the loop is about checking if we should leave the loop, or maybe execute another iteration. I want to note something else about this loop. In this loop, ECX does not increase. It decreases in every iteration. We can see it by this instruction, decrease ECX. What this actually means is that we store the values that we get from the user in the opposite direction. We begin from the right, or maybe from the last D word of keep nums, and we go all the way to the first D word inside the array keep nums. We can see it from this formula. ESI equals keep nums plus 4 times ECX. Imagine that ECX begins from 5, then it is decreased to be 4, and in every iteration it is decreased. Therefore, the first address that we are going to have is keep nums plus 16. The next one is keep nums plus 12, and the next one is keep nums plus 8, which means that we go backwards in memory. We are going backwards because we want to have the inverse effect. We want to reverse the numbers that the user gave us. Therefore, this loop has the job both of reading the numbers from the user and also the job of reversing the numbers. It stores the numbers in memory in reversed order. What it really means is that the next loop can just print the numbers from memory in the order that it sees them, and this order will be the reversed order. Just to make sure, let's go over the second loop to understand what it does. It initializes EDI to be 5 and ECX to be 0, which means that this time ECX is going to be increased in every iteration. We can see it by this instruction. In every iteration, we first calculate the address of the word number ECX, pretty much the same like we did in the first loop. We just multiply by 4 and then add the value to keep nums. Then we read the D word from the memory, from location ESI. Note that this instruction looks pretty much the same as this one. Storing is pretty much like reading. It is only that the order is different. In the first instruction here, the destination was the memory location. But in this instruction, on the second loop, the source argument is memory, and the destination is EAX. Next, we print the number EAX to the console, we increase ECX, and we move on to the next iteration, or maybe exit the loop. Pretty much a simple program, however it is a pretty good demonstration of using the memory and using the move instruction to access the memory.